Hi, I'm Sam Kamenetz. I'm a software engineer at Bread, and I love using debuggers. And I'll candidly admit, it took me a long time to figure out how to use Go's debugger. Debugging a Hello World application was easy enough, but I got flustered by more complicated setups I encountered in my day-to-day job, like debugging a test or debugging a Dockerized application. So I learned how to configure a debugger for almost every scenario. In this talk, I'm going to demo all variety of debug configurations, as well as how to reason about them so you can become a debugging expert. I'll be talking about VS Code's debugging features as well. Now, this talk isn't just for debugger enthusiasts, it's also for the debugger skeptical. For all of you, my pitch is this. Setting up a debugger requires understanding the nuances of how the debugger, project, and IDE interact, and it can feel like too much work to set it up while you're hunting down a bug. But here's the thing, it's a time investment, but it's a one-time investment. Once you configure your tooling, you can debug at will, even at the press of a button, and from there, it's really just setting breakpoints. Before we get into the how of the setup, I want to show you how awesome debuggers can be. It's easier to make the pitch when you're actually excited about what debuggers can do for you. First, debugging without a debugger can get a little mind-numbing, especially when you're in what I like to call the tweak, build, run loop. So you ever find yourself writing code like this, just a bunch of logging and prints, adding a new one each time you compile? Obviously, debuggers help avoid this, but they can also do a lot more than that. I think that one issue is that most people don't even know everything you can do with a debugger. So here's just a few use cases. Say you have a function that's called in many places, and you aren't sure what call chain represents the error case. You can inspect the call stack with a debugger. If a test is failing, you can launch a debugger against the test itself. Say that's running fine locally, but you're having issues in the Docker container. You can launch the debugger as part of the container. Let's say you're getting an unexpected nil pointer dereference. You can just set breakpoints and watch the value mutate as execution proceeds. All right, so everyone's familiar with the basic debug operations of setting a breakpoint and running to hit it. What you might not necessarily be familiar with, though, is that when you're using a GUI debugger, you get access to all of your local variables and you can see them updating in real time. Also, you have access to the call stack where you can see each of our Go routines, and currently the one that we're paused in, and see that we're currently in the playground function, which was called by main. So suppose for a minute, though, that you didn't particularly care about seeing all your local variables, but you wanted to focus on one. This is where our watch window comes in. So let's go ahead and just focus on one expression. Let's go ahead and keep on watching I. And now as we run through, we can watch that update again and again as we go through a loop. But suppose that we want to have things run a little faster. So let's go ahead and set a conditional breakpoint. And we'll say the condition is, I mod 10 is equal to 0. And let's also add a log point where we'll just say, hello world. So let's see that in action. So as you can see, we're incrementing by 10 each time in our watch window. And when we go ahead and look at our debug console, you'll see that each time we run, we're hitting hello world 10 times and incrementing the same amount. So that's pretty cool. Suppose that you wanted to run a debugger, but not by typing in all these commands at once or clicking around. Well, you can use something called debug scripts. And you can see here we have just a simple text file populated with basic commands that you would enter into the command line debugger. And it's pretty analogous to our previous example. So we're setting breakpoint B1, trace point T1, and we'll go ahead and setting so we're only hitting B1 every 10th time and printing I each time we do that. We continue a bunch, then we set I back to 0 and see what happens there. So let's see this in action. So that was kind of a blink and you'll miss it situation. So let's go ahead and see what we're doing. So you can see right away that we're setting our breakpoints and we're hitting our trace point T1, and that's just printing out the name of the function that we're in each time we go through. Finally, we pause when I is equal to 9, and you can see our printout of not only the value of 9 of I, as well as our source code. So we go ahead and do that, and you can see that we're incrementing by 10 each time until finally we get to 59, in which case we set I back to 0. And then the next time we run, I is equal to 10. So suppose that you want to launch a Docker container and then also debug it all in the same click. Well, you can do that too. Observe. You can see that we're starting our command right here. Flipping to orange indicates that we are good to go. Let's set a breakpoint and run from here. And of course, in the words of Dr. Facilier from Princess and the Frog, there are things I haven't even tried. Namely, RR debugger integration, which lets you rewind execution of code. There is a native debugger adapter protocol support built into the most recent version of Delve. I'll unpack what that means later on. And then I showed you earlier in the demo that there are debug scripts. One of the features of Delve is that you can use Starlark, which is a dialect of Python, to enrich your debug scripts. Full disclosure, I never heard of Starlark until I started digging into Delve's documents. Safe to say, debuggers are very, very useful and make your life easier. My goal is to show you what Delve can do and how you can set it up for yourself. For each scenario, I'm going to show you how to launch Delve as a command line application and then show you how the same configuration works when run through VS Code's GUI debugger. So, why use the CLI? Well, even if it's not the most ergonomic way to run a debugger, it's a really good basis for understanding the commands before we introduce layers of our tooling. My approach is to start simple and work up from there. And you also might be wondering why we're using VS Code. Well, VS Code is ideal because it's a common tool that's highly configurable and has robust debugging capabilities. A lot of my coworkers like using JetBrains Golang IDE since debugging usually, an emphasis on usually, works out of the box. I prefer VS Code in general and for debugging because the debug settings are much more flexible. There's some really cool things you can do with it, and it's also really easily portable. For instance, you can include the debug configurations as part of the version control. We'll touch on that more later. Oh, and one programming note, if you'll pardon the pun. If you have VS Code, the Go extension Delve, you can pull my repo, the one that I'm demoing right now, and follow along. On to our first demo. Let's start with a simple web server running locally. Okay, couple things to point out here. Just for convenience, I'm printing out the first part of the Delve debug help command, and then the actual payload is on line number 2 here, where we're running the actual Delve debug command, and then we're separating the debugger commands from program arguments with this double dash right here. Side note, you're going to see this a lot in all my examples where we're setting this environmental variable and then also including this program argument because my program requires that. Also, I'm using make files because you should never remember something that you can make a computer remember for you. If you're not familiar with makefiles, you can think of this as just a collection of very short bash scripts that each have an alias within all one file. Very convenient, especially when you're setting up debugger stuff. So let's go ahead and actually see this in action. All right, so we've launched our debugger, and once it's ready, we'll see the interactive Delve prompt. Let's go ahead and set our breakpoint on line 25. And then we'll continue
And then you'll actually see where we're requiring that environmental variable and our program argument. All right, so now that we figured out how to run that in the CLI, let's talk about how we run the same example, but in VS Code. So, quick side note, I'm not going to invest time in showing you how to set up VS Code or the VS Code Go extension or Delve. There are plenty of guides online that can teach you how to do that. Instead, I'm going to focus on our launch.json here. If you're new to VS Code and you're not quite sure what a launch.json is, you can think of this as basically every run configuration that we've specified here. So every JSON blob is represented here as an item in this drop-down menu. And each of these is a different run configuration that launches our debugger with a different set of parameters.
Now, the best way to understand how to use a launch.json is by referencing the official docs, namely for VS Code and for the VS Go extension. These pages were largely how I built this demo.
First attribute here is the name, which corresponds directly to the name that we see in the drop-down menu right here. Type refers to the language and tools that we're using. We also have a request for every configuration. This can be launch or attach. I'm going to touch on that later. We have mode, which corresponds almost directly to the equivalent command line invocation. Program specifies the working directory where you can find the source codes and the executable. Here we're using a special VS Code variable workspace folder, which maps to the current folder that you're working in as part of your editor. We specify stop on entry, meaning that we stop right at the top of program execution, so we can then set up breakpoints and then resume execution. Finally, we have the somewhat self-explanatory args, which are our program args, and then setting environmental variables for the duration of the run of the debugger. So let's go ahead and see this all in action. We hit the plus button, and then we go over here. We can set our breakpoint. And there you go. So let's go ahead and now run this. So we're going to go ahead and set our breakpoint right here. And also, just to illustrate a future point, I'm going to set a breakpoint right here. So we hit our breakpoint. We're running now. And let's go ahead and actually activate our server. Host 8080 ping. And you'll see as we hit this root, the editor actually retakes focus as well as stopping at the breakpoint, which is pretty cool.
Now, suppose you want to figure out why a test is broken. Well, Delve can do that too.
Actually, going ahead and looking at this, it's pretty simple. The only real difference is that we're setting mode to test, again, analogous to our delve test command. And then for program, rather than just specifying the workplace folder, we're then additionally specifying the subdirectory some package. So let's go ahead and see that run. Looking at a launch.json configs for this, there's actually not a whole ton happening here. As you can see, everything's the same except for we're running mode test corresponding to delve test. And then for program, we're specifying rather than the workspace folder, we're specifying its subdirectory some package because that contains the test that we want to run. So let's go ahead to some package.test, set a breakpoint right there, and we'll run, and we'll hit it right then and there. And you can see this testing object and all of its nested structs.
So earlier in the demo, you saw me using logging points. That's analogous to the functionality of Delve's trace point, which is a breakpoint that doesn't stop execution but logs to standard out. So you can activate trace mode in Delve, meaning every function matching a regex will have tracing, but execution will not be stopped.
So again, looking at this command, pretty basic. The two differences being that we're saying delve trace, and then we're specifying a regex for all the functions that we want to call. In this case, we're really going to just be calling get message as part of the trace program. So let's go ahead and see this run. And remember that trace doesn't actually stop execution, it just sets trace points at all the designated functions. So when we go ahead and run curl localhost 8080, we're going to get a response. And here, in addition to our gin logs and our console.out, we are going to also see these go routines, get message. This is part of our trace point. So you'll notice that I actually do not have a debug configuration for number 3 because there is no direct equivalent in VS Code's functionality for the delve trace command. However, you can mimic that with something I showed you earlier, which are VS Code's log points, which more or less map to the functionality as a trace point. So let's go ahead. We'll run our original example here. But rather than that, we're going to set breakpoint here, and we're going to add a log message right here, and we're going to say example3. So we run, and then when we run again, we're going to see example3 show up in the debug console. And there you go.
Before we go into more complicated examples, let's talk about how debuggers work. The correct mental model will help you reason about configuring your debugger. Now, I'm stealing this slide from Alessandro Arzili's 2018 Gopher talk about the internal architecture of Delve. His talk goes into full detail of the architecture, but the gist is that Delve contains a client representing the UI and its service layer, and then a server which maps the symbols of the program to memory addresses and manipulates execution of the program itself. This separation is what allows us to support running a debugger on, say, a different machine, be it a remote server or container, as well as connecting to different UIs. When we use Delve via VS Code, a debug adapter, which ships with the VS Code Go extension using the DAP, or debug adapter protocol, allows the IDE to serve as the new front end instead of the CLI interface. It uses the UI actions that are standard to VS Code and converts them into RPC requests to the server. It also handles launching the server process, for instance, launching the debug server via the headless option. The newest versions, which must be opted into, natively support the DAP and require no separate adapter. Now that we understand the client-server model, let's try attaching Delve to an already running program.
So you can see that I have defined this somewhat verbose command, but this is really just building our executable. One thing I want to point out here is our GC flags. And what this is specifying is that we are building, the N signifies we're building without compiler optimizations, and then the -L signifies that we're running without inlining, both of which are compiler-based optimizations that can interfere with how the debugger actually interacts with our running program. So let's go ahead and see what else we need to do. We have our make dry run, which is pretty basic. We're just running that built executable with our environmental variable and our program argument. And then we're going to do make debug patch. And simply what we're doing here is we're just printing out the PID based off the executable name. And then we're running the delve attach with no arguments. All right, so let's go see this running in action. First we're building, then we run. Now let's go ahead over here and actually attach to our running program. Okay, so we're in the debugger. I'm going to go ahead and set breakpoint on line line 8. And since we're broke at startup, we're going to say continue. So now we are freely running. And let's go ahead and curl our endpoint here. You can see now that we've broken in the actual function. And now after we resume, we see that we get our message back. Okay, so let's go ahead and talk about this launch.json configuration. So you'll notice here that we're running request hatch instead of launch. Now that you've seen a few examples, I want you to think of launch as basically saying this debugger command is effectively starting the process that will also be debugged, versus attach is much like running on a train and jumping onto it, simply attaching to an already running process or already running debug configuration. Finally, we also have to specify a process name that we're connecting to. Here, instead of using a randomly generated process ID, we can just give it the name of the process itself. So let's go ahead and run this. So we're now running our debug executable. And now in our VS Code window, we can go ahead and actually attach to it now. So I believe we should be able to go into package, set breakpoint, and then we go ahead and curl, and then we hit it.
Now, let's debug with a separate debug client and server. You can think of this as debugging a program on another machine. This isn't a scenario that I encountered much as a backend software engineer, but when I was writing embedded software, we'd load the application onto our custom hardware in a different building and launch the debugger against that. Even if the use case might be a bit special case, it's a good stepping stone to our most complicated example, debugging a Dockerized application.
Okay, so there's a few flags here that I want to call your attention to. First off is this accept multi-client. Basically, this allows multiple clients to connect to the same debug server instance, which makes it easier for us to actually disconnect and reconnect to the process. Then we have headless, meaning that we are launching just the debug server, waiting for a client to connect to it, rather than launching both the client and the server in the same process as we were doing previously. Finally, we're specifying a listen, localhost 40,000, just to make it deterministic as opposed to listening on a random port. And we're specifying API version 2 because my command line version of Delve runs by default on version 1, but this allows it to use VS Code client, which is running the API version 2. So let's go ahead and look at the command that we're actually using to connect to this debug server. And as you can see, we're doing delve connect localhost 40,000, specifying that we are attaching at the exact address that we specified for our listen. So let's go ahead and see this in action. Okay, so now we are listening. And let's go ahead and say make debug connect. Now we're connected on port 40,000. So let's go ahead and set a breakpoint at some package. Let's just make sure that we're continuing. And then let's go ahead and curl localhost 80 ping. And you can see that we've hit our favorite message. All right, so looking at this, you'll notice the key difference is that in our launching against a running process, we were in mode local, but here we're in mode remote. And basically that's just for when we're in the attached configuration. That's toggle from looking from a process ID to a host and port to connect to. So, and you can see right here, we're also specifying the same host and port that we're expecting to find our debug server. So let's launch this by first running our debug server. Looks like we're up and running there. And we're on example 5, launch against server. Okay, so now that we're running, we'll set this breakpoint. Here we're going to curl localhost 8080, and we are able to hit our debugger. Pretty cool.
This is actually returning to the first example I showed. Debugging a Docker container is probably the configuration that requires the most steps and knowledge. Luckily, we've built up to this point. I'm also showing how to set up pre-launch tasks in VS Code, which is critical to automating setup for many debug configurations.
Okay, so the first thing that we're going to want to do is actually take our Docker file and modify it so it supports debugging. There are two elements I really want to focus on here. First, you have to add this go get delve command, so the actual Golang image has access to the delve executable. The next thing that you should focus on is that we are using CMD. Now in Docker files, remember that entry points cannot be overwritten when you're doing Docker run. CMD executes when you do Docker run, but can be optionally overwritten with a new run command when you're actually invoking Docker run. Now, if this solution feels kind of ugly to you, you can always just make another Docker file and call it Dockerfile debug and run that instead. So as you can see, this is just a fairly bog standard Docker build command, just specifying the name of the image that we're building. So let's go ahead and just execute that. And since we're cached, it builds right away. So let's actually take a look at the command that we need to actually run and invoke the Docker container. So there's a lot going on here right now, and it's kind of hard to read in the format. So let's go to the slide for this.
The first line is how we are running the Docker container, and the second one is the command we are launching with. Remember, we are overriding the CMD that runs by default for this container. For those of you that aren't super familiar with Docker, we built our container and now we're running it. We're exposing port 40,000, meaning it's reachable outside the Docker container, and then via the publish flag, mapping the container's port 40,000 to the host machine's port 40,000. We could also expose it within the Docker file as well.
Okay, so now that we've already built our Docker image, let's go ahead and run that as a container. All right, that's looking good to me. Let's flip over and then connect to that. We'll go ahead and set a breakpoint right here. We'll continue, and then we'll just go ahead and ping, check back in our debugger window, and you'll see that we've hit our breakpoint as expected. And we're back in the prompt. However, the source code isn't loading. Now, this originally caused me a lot of consternation, but simply put, after debugging a bunch, I realized that the root of the issue is that because there was a mismatch between the paths on my local machine and on the paths on the remote Docker file. So the Docker file has everything under the /app, and locally everything is under my Go source, so on and so forth. This is where keeping the client in server model really comes in handy, but since the paths don't match up, we aren't able to find that file, and hence why we're getting the no such file or directory right here. All right, so let's go ahead and open up our hidden delve configuration file. In addition to a lot of other things that you configure, what we want to focus on here is the substitute path. And remember that this is just mapping the source code that is configured within the actual Docker container to what's on our local machine. And this is from the perspective of the debug server. So the from is actually in the Docker image itself, and the to is where our client is on our local machine. So let's go ahead and uncomment this. With our configuration changed, let's go ahead and rerun the debug server. All right, and let's go ahead and connect to that. Now we will go ahead and set a breakpoint. And with the proper configuration, we are now able to actually see our source code in the debugger. Let's break down this part of the run configuration. This one is really based off of our connecting to a debug server because conceptually it's really similar, just with some of the nuances of it actually running in a Docker container. The two things that I'm going to point out that are different are, first off, I'm using the substitute path, which is essentially exactly the same as what we did in our delve configuration. However, the from is actually our local path, and then the to is to the remote path. Because remember, this is from the perspective of the client debugger instead of the server this time around. The other thing that's happening here is that we have a pre-launch task, which basically is running our Docker image for us. We're going to touch on this in just a little bit and break that down. That lives in task.json. Then, of course, we have our stop on entry. And then we have these two commands, show log and trace. Basically, both of these are what I use to get logs from the debugger itself to help troubleshoot this issue when I first encountered it. This is a great step if anything's acting kind of wonky with the debugger in general. Okay, so let's go ahead and run and debug this Docker container. Now, you'll actually notice this is the example that I showed you at the beginning of this talk. Something I'd like to point out is that we've actually waited for the API server to start listening before the debugger actually launches.
So you saw in the last example that we were able to run the Docker container and start the debugger all in one click. That's thanks to the magic of tasks. So for context, VS Code allows you to define arbitrary tasks. Normally these are used for configuring file watchers or linters or other such tooling. They live in your project's task.json if you've defined any task. Since we aren't setting up one of those tools, the configuration can be a little hard to follow. Namely, it expects a pattern of files and regexes to trigger, so we have to fill in dummy values for this. And remember, we are invoking this as part of the debugger.
Okay, so this is our task.json file, and we're looking at the task that gets launched as part of our debug Docker launch configuration. So the command to define is actually pretty simple. This is just what you would type into the shell. Where it gets a little bit more complicated is that since this command doesn't technically halt on its own, it has to be manually halted, we have to specify it is a background task. Further, we have to specify at what point that VS Code can stop waiting for this to finish and then go ahead and launch the debugger. So here I've defined this in this background object where we're saying that once we see the pattern appear in the terminal API server listening at, we are good to go ahead and launch the debugger. Mastering the task.json can be a little tricky, but it's the key to becoming a VS Code and Delve power user.
I'm hoping you feel empowered to set up debuggers for your most common Go repos. You'll have to rely on the manuals to build that launch.json, the manuals being VS Code docs and the Go extension docs. Specifically the bits about configuring the launch.json. You'll also have to rely on a bit of trial and error. The setup can be a hassle, but once you make that launch.json file and lock it into your repo, you are set for your whole team. I've already touched on some extra mile things you can do there, like pre-launch tasks and debug scripts, So go out there, give everyone on your team a new tool in their tool belt.